Hello and welcome to our project's video where we'll be explaining the montante and cramer method, which is basically Cramer's method with cofactors. So to begin working on this method, we'll take a closer look to the top right corner of the screen where you'll find our three variable equation system, which consists of x, y, and z variables. The first step to solve this system is to arrange all coefficients into a matrix, aligning one same variable into one same column. In our case, the left column contains the x coefficients, the middle one contains y's, and the right one contains the z's coefficient. Now that our matrix is created, we'll select the top left digit and set it as our pivot point. Once our pivot point is selected, all those numbers that are not in the same row or column will be inside an imaginary box. And with everything set it up, the only thing left to do is to multiply the pivot point to any of the numbers inside the box. But to keep it clean and simple, we'll multiply it by the box's top left digit. Then we'll get the only two numbers that are outside the box that are in the same row and column as the box's number we just chose and multiply them as well. And with these two new values, we'll subtract them together and get our new digit that will be placed in the same row and column as the number we chose inside the box, but in a new 2 by 2 matrix. Maybe this was a bit hard to follow, but as our pivot is digit 2, we'll multiply it by -2, and then the only two numbers that are in the same row or column that the -2 that are outside the box is 3 and 1. So we'll multiply 2 times -2 minus 3 times 1, which will give us -7, and we'll put it in the top left corner of the new matrix, that is -7, and we'll repeat the same process 2 times 4 minus 1 times 1 and put it in the top right corner, that will be 9, and 2 times 1 minus 3 times 3, that will be -7 again, and will be in the lower left corner, and 2 times 2 minus 1 minus 1 times 3, that will be in the right lower corner. With this new matrix, we can get into the second step, which is finding the determinant of the matrix. And theoretically, we could make the whole process again, getting a pivot point and the imaginary box and everything, but it's easier if we just multiply -7 times 7 minus 9 times -7 like across. And then we'll get 14 and we'll divide it by the previous pivot point. If you remember, it's 2. So our determinant or the determinant of the matrix will be 7. As you notice, this step was much simpler and much faster, so we pass into the third step. So in a quick overview of step 1 and 2, what did we do? We got the determinant of the matrix, of the original matrix, but now we're going to change things a little. If you noticed in the new matrix, the first column is no longer the x coefficients. Now we have the answers of the equation system. All the answers of all the equations are in the left column where the x coefficients should be. So now we're going to get the determinant of the matrix, but it's going to be like the x determinant. And the process is the same. We'll get our pivot point, we'll have our box, our imaginary box, and we'll multiply 7 times -2 minus 3 times 1. It's going to be -17, and we're going to put it in the top left corner, and we're going to repeat the process all over again. But the only difference, it's going to be that the left column is going to be with the answers instead of the x coefficients. In screen, you can see all the operations, and we're going to pass now to the step 4, which is going to be the same step again. We'll multiply -17 times 22 minus 29 times -29 and divide it by the previous pivot point, which is no longer 2, it's 7. So the determinant of the X matrix is going to be 57. Now into step 5 and 6. The matrix once again changed. Now the x column has the x coefficients, but the y column has all the answers of the equations. So we're gonna get the determinant of the of the y matrix, and the process is the same. Again, 2 times 1 minus 7 times 1, it's going to be minus 5, and we're going to put minus 5 in our new 2 by 2 matrix. Then 2 times 4 minus 1 times 1, it's going to be 9, and again and again and again with all the other values in our y matrix. Now with our new 2 by 2 matrix, we're going to apply the same cross multiplication. It's going to be minus 5 times 7 minus 9 times 3 divided over the last pivot point that is now 2 again. And it's going to be minus 31. Lastly, to find the determinant of the set matrix, we have the pivot point again, and the answers are going to be in the set column. We'll multiply 2 times minus 2 minus 3 times 1, it's going to be 7. 2 times 1 minus 7 times 1, it's going to be minus 5. We're going to repeat the process, and we'll multiply minus 7 times 3 minus 5 times minus 7 over 2. That is going to be the new pivot point. It didn't change, but you always got to be careful with that, and the answer is going to be minus 28. Lastly, we can pass to the final step, which is finding the values of x, y, and z, knowing that the original determinant was 7. Now, to find x, the only thing we have to do is to divide the x determinant over the original determinant, so it's 57 over 7, and it has no more simplification, so that's the answer. Also with y, it's minus 31 over 7, no more simplification needed, and z, the answer will be minus 4 because it's minus 28 over 7. Thanks for your attention.